So
yes.
Let Aniruddha share his screen. I'll wait a minute and till people join in, and then I will start.
Okay.
Yeah.
Sure. You might want to minimize the picture-in-picture screen on your screen, Aniruddha.
So it is, I don't have a control of that, right? I mean, okay, this one you're saying. Okay, got it.
Yeah.
Yeah.
That one there.
Yeah. I thought my video.
Yeah.
We have already like almost 30 people. Yeah.
Yeah.
Let's start. Yeah.
Yeah, it'll start automatically in 1 minute. So I'm just gonna go on mute, and I'll give you I'll ping you on the chat as soon.
Hi everyone. Can you hear me? All right. We'll start in a minute or so. Just waiting for some couple more people to log in, and then we'll start right off. Cool. Cool. So let's start off. So welcome to Scale Up Thursday webinars. My name is Vinayak Hegde. I'm the CTO in residence at Microsoft for Startups. This is the second in the series of webinars we are doing, and the first in the technical series. We will have a new topic every Thursday. Today we have Aniruddha Deswandikar, who will talk on cloud scale analytics. Later in the series, we will have a talk on computer vision and cognitive services, followed by a session on serverless. In between, we will also have discussions and webinars on business topics as well. So watch out for every Thursday. I'll quickly introduce the topic, which is cloud scale analytics today. In today's competitive world, speeding up of analyzing and predicting your business can be the game changer for startups and enterprise alike. Data warehouses are no longer simple OLAP versions of OLTP databases. Structured and unstructured data coupled with machine learning has transformed the data warehouse of the past into the amalgamation of disparate data sources, data lake, and collaborative data analytics tools. Setting up a complex environment like this can be a daunting task and can take away time from your engineers who otherwise could be building cool product features or building intellectual property. This session on cloud analytics will walk you through the advantages of Azure's cloud. Just give me a sec. Azure Cloud provides in terms of jumpstarting your analytics and ML efforts. We'll start with a map of all the technologies available on the Azure Cloud and then talk about three specific technologies: Azure Data Warehouse, Azure Data Explorer, Azure Automated ML. A little bit about Aniruddha. Aniruddha Deswandikar has about 27 years of technology industry experience across startups, consulting, and Microsoft. He has been with Microsoft for 14 years. He started off at Microsoft as a technological architect at the MTC, which is the Microsoft Technology Center, and later managed the Microsoft Technology Center and a team of architects. Until recently, when he moved into the customer success division as director of data and AI, and he's also a principal architect for strategic AI initiatives. Aniruddha is extremely passionate about solving tough business problems for Microsoft customers. Currently, he helps customers realize their digital transformation dreams through big data processing, advanced analytics, and AI. Before Microsoft, Aniruddha has worked for Netflix.com as a senior developer and helped build systems for Netflix internet scale business. So over to you, Aniruddha. But quickly before that, let me just talk about the social media challenge that we have been running. Let me just share the slide for that. So as you can see, we are going to send a swag bag from Microsoft for startups for people who post about this webinar. You please use the hashtag #ScaleUpThursdays, and you can post it on Twitter. And the best tweets that we like, we will declare a winner at the end of the webinar, and post him or her a swag bag. So with that, we move on to our speaker, Aniruddha Deswandikar, who will talk on cloud scale analytics. Over to you, Aniruddha.
Yeah, hold on just a second. Let me share my screen. I'm going to switch my video off.
Aniruddha, we can see your screen, so we can start.
Okay, hold on one second. Let me, because it's taking a long time to refresh here. Yeah. Okay. So welcome everybody to this first technical series, which is a part of the Highway to 100 Unicorns Scale Up Thursdays. And thank you for the introduction, Vinayak. So today, as Vinayak said, we basically will be discussing cloud scale analytics and the advantages of cloud scale, of using the cloud for analytics and all the various tools that are available to us. So from a session agenda perspective, we will cover cloud scale analytics in general in terms of what has changed, the past few decades, on how businesses have changed and how analytics in general has changed. We will look at some analytics architectures, some typical, you can say, best practices or some ways in which industries are using analytics. There are about 6-7 patterns. I have managed to bring it down to about 4 common patterns. We will look at some scenarios, advanced analytics scenarios in various industries, and how it impacts their business and how it impacts their core of their business when they actually do advanced analytics and really give importance to data. And then we'll look at 3 technologies. We'll look at Azure Data Warehouse and the architecture of how it has been set up, what are the various components, and we'll look at Azure Data Explorer and Azure Automated ML along with a demo that I will show so that everyone has an idea of how to do these things. And then we'll open it for Q&A. So I wanted to start with this slide, which is a statement from Satya, which just sort of emphasizes the importance of data in today's world for businesses, and this is applicable to everybody. It is not just about a large company, small company kind of a thing. The number of top companies that have recently been displaced from their position just because of an incumbent competitor who has managed to use data to their advantage and is quite staggering. And so it's no longer just a big small company thing, but it's all about how you use your data. The way I look at it, it's basically if I look at my personal 3 decades of experience across in technology and all the changes that I have seen personally in the industry, The first, if you look at the 1990s, it was all about automation. It was all about, the buzzword was computerization. People were installing, accounting packages. People were writing ERP systems, CRM systems. Though everything was very siloed, everything was running on a PC or a small network. The idea was to automate the business, reduce paperwork, and start collecting electronic data into these systems. And so the next decade, which basically about, say, you can say from about 2000 to 2010, the world was all about collecting data because computerization was done. Everybody was using computer systems. But
Aniruddha,
yeah.
sorry to interrupt you, but your slides are not moving for some reason. Can you check that?
So I can see my slide here. Are you able to see now? Or
go back a little bit, maybe at Satya's slide.
Yeah, I'm at Satya's slide now.
No, still not able to see it. Can you try resharing it once?
Sure. So I'm seeing a circle here. Is someone else trying to share a slide or something? Let me try it again. Can you see it now? Hello?
No, Aniruddha, not yet.
Okay. Because I have shared it.
Yeah, we can see it now. Yeah.
Yeah, you can see it now? Okay.
Yeah.
Okay. So I was basically saying that the 2000 to 2010 decade was then all about data collection because computerization was over and everybody was using these systems, and as a result of which basically a lot of data was getting collected. And people were sort of doing, basic reporting against this data and things like that, trying to sort of analyze their business in a way that in a very reactive way. And then basically from 2010 to now, basically 2020, that's the decade where, a lot of people realize that they're sitting on a lot of data. The cloud had taken off, so computing was easy to get, cheap computing and storage was easily available. And so concepts like machine learning, advanced analytics, predictive analytics, forecasting, and things like that took up a lot of speed. And people realized that if somebody has a lot of data, then they are able to very easily predict their business, predict the market, predict competition, and stay really ahead of the curve, and be able to sort of navigate their business through the market based on this analysis. And hence today, there are these cliched statements that data is the new oil or data is the oxygen for retail. All those statements are now applicable mainly because of all the compute and storage and all these nice tools that are now available to people to actually do their analytics. So moving on to the next slide. So some of the, so Vinayak, are you able to see the slide now?
Yeah, I'm able to see.
Okay. So here are some common barriers to basically getting value out of data. Obviously, one is data silos. People tend to build their data in different systems, and then only that system is accessing the data. This can happen at different levels. With enterprises, it can happen at a system level where different systems and teams of people who are actually maintaining those systems have access to that data, and then no one else gets access to it. At lower levels, at a developer level, also things can happen where data is sitting on a developer's laptop sometimes in Excel sheets and things like that, where again it's not being shared by anybody. We also have this new trend of what we call as incongruent data types, where different types of data is no longer the world of only OLTP. We have, we are analyzing a lot of unstructured, structured data around us. So that also is a challenge from an analytics perspective. Performance constraints, again, limited resources on-prem. You already invested in some machines. Recycling these machines and getting new machines is always a challenge, and hence performance becomes a bottleneck. With all the open source tools available and all the enterprise tools available, the complexity of the solutions also rises because you now have to actually maintain all these different systems that you install, and have to have uptime on those systems, have to have backups of these different databases and things like that, and it just becomes a very complex solution to manage. And of course, the rising costs because of all these problems. So to solve those, basically from whether it's an on-prem or a hybrid or a kind of a solution, what's important is to get to a data hub. And this is something, more and more companies are coming into this concept of a data hub. They also call it something called as democratization of data, where once you get all the data required to do your analytics into a single place, then you are able to very granularly and nicely control access to that data. You are able to sort of divide and manage that data in different buckets of PII data, and secure something that needs a lot of security, something that doesn't need a lot of security. You can sort of segregate all that data in a central hub and give access to everybody. So more and more we are seeing companies where they are saying, hey, we want to liberate our employees by giving them access to all our data, especially accessible data, or rather non-PII and non-sensitive data. And anybody who has an idea about doing something should be able to have access to that data without jumping through a lot of company loops of getting access and raising requests and things like that. There's also now a support for diverse data types, thanks to technology again, like Hadoop and others, that you are actually able to really process diverse data types and bring the all the intelligence into a common framework. You have unlimited scale thanks to the cloud again, thanks to the also cheap hardware and software hardware and compute that's available and storage that's available, that you are now able to sort of go with an unlimited scale to petabytes of data that you can put in the cloud, just linearly scale your compute without having to worry about adding more machines and procuring more machines. There's a familiar tool and ecosystem also that is now available on the cloud, whether it is your notebooks like Python, like your Jupyter notebooks, or whether it is some other analytical tools. There is a common set of tools and ecosystem that is being developed that people are using and are very familiar with. And then you have the lower cost of ownership. Because you're on the cloud, you don't have to upfront invest anything, and you can get started very quickly without spending a lot of money. So let's take a look at the modern data warehouse. So if you look at a data warehouse, the traditional data warehouse, it used to be basically an OLAP version of the OLTP database, which the OLTP database was basically a relational model of your business. And what you would do is basically, just to make sure that you are able to fetch a lot of data very quickly, you just sort of transform your OLTP database into an OLAP kind of a structure, which means it could be a denormalized format of your OLTP. If you want to sort of quickly get a lot of data without doing too much of joins, or it could become some sort of a columnar store where you want aggregates to be computed and things like that. Or it could also be, a little bit more advanced would be like some sort of a star schema where you can do some dimensional analysis across your data and things like that. But
sorry
yeah.
to interrupt again. I think we can't see a slide.
Oh. How do I solve this problem? Okay. Are you able to see now? Are you able to see derive value, or what are you able to see?
Yeah, we could see derive value, but like the next slide that you changed, we could not see that.
Are you able to see now?
We can see. Now we can see.
Okay, so I think there is a lag of some sort. Okay, so as I was saying, basically the traditional OLAP is no longer applicable, because if you look at the left-hand side here, you no longer just have systems that are delivering data. You have, graph databases, you have images, you have social, Twitter databases, you have data, or you have even, your IoT sensors getting data into the system. And so no longer a traditional, a typical standard Microsoft integration services is going to help you. Because now you have to process a lot of data, unstructured data, change it in its format, make sure it's cleaned properly, and then put into a store for analysis. So that sort of changes the entire, data warehouse structure, and you now have a much more sophisticated way of even ingesting. And in fact, now, the way things are. The first 3 boxes, or almost you can say the 2.5 boxes, are really a field of something called as data engineering, where we need trained professionals to actually understand the data that is coming in, be able to sort of transform that data into something that is usable. So if I have to map this to technology, just from a pure, individual technology perspective, it falls into something like this. So instead of using traditional integration services, we now have something called as Azure Data Factory, which helps you, from any source to any source kind of a transformation that you can do. So, you can bulk copy the data, you can take the data, transform it, and then copy it into multiple sinks, data sinks and things like that. You also have now a choice of storage. Storage is no longer just a relational storage or just some sort of a file system. It is a combination of everything. It's a distributed storage. So if you look at our data lake store, for example, the latest version, it is actually a distributed HDFS store that we provide, which also acts like a blob. And so you have one common storage that you can use to have like an HDFS type of store, or a simple blob store, where you can store any kind of documents and images and things like that. For training, again, you have preparing and training, you have multiple tools. You have something called as Databricks, which are basically nothing else but collaborative notebooks that you can create, where data engineers and data scientists can work together. And as I said, I mean, it's 2.5 boxes belong to data engineers, and the remaining 1.5 box is really data science. And these people have to collaborate at some point. And technologies like Databricks will help you do that, will help you the data engineers can do their job, pass on the notebook to the data science, and then the data science can do their job. So it also helps in collaboration, it helps in DevOps. Similarly, we have HD Insight and Data Lake Analytics, which again will help you do batch processing on data, especially on Hadoop-like data, and give you the ability to process large quantities of data into models. Then you have the data warehouse, which of course has all the models stored, and this is where they are now from here served to different consuming technologies. So it could have been, whether it's internal reporting, whether it's it could also go to applications and things like that. So let's now look at the advanced analytics on Azure and see what all things we have on Azure. Vinayak, are you able to see the slide?
Yes, we are able to see.
All right. So, first of all, as I mentioned in my previous slide, you have now various types of, data that is coming into the system. So you have sensors, you have, log files and media files, and also structured data coming from business apps. which then can be put into a long-term storage. Again, from long-term storage perspective, we have all these different choices. So you can put it into a data lake store, you can put it into regular Azure storage in the form of tables, queues, and things like that. You can use Cosmos DB, which is our version of NoSQL database, or not really version, but basically a wrapper on top of the traditional NoSQL databases like Mongo and Cassandra and Graph APIs and things like that. And then you have your traditional SQL databases that can be also used. For orchestration, you use Azure Data Factory, which is our premium product for doing any kind of transformation from the source to the sink of data. From analytics perspective, you again, as I said, you have all these three different, Databricks, HT Insight, Data Lake Analytics. For model and training, you have Azure ML. We have Azure ML Studio, Server, ML Server, Databricks. You can also use the ML capabilities of SQL Server, which we recently introduced to do your ML. And you can do batch AI kind of processing, also on this. From a trained model hosting perspective, again, if you want to host these models, you can do it through Azure Container Services, or you can host them in SQL Server also. But there are other ways of doing it. Like, for example, you can also directly post Azure Databricks notebook to a Power BI kind of this. So there are other ways of doing that also if you want to do it. And then the serving part of it, which again can be Cosmos DB and SQL DB if you want to do application related, consumption, and I'll give you examples of these a little later, or you can go by the traditional data warehouse or analysis services that can deliver to Power BI and use for internal reporting and internal, analysis. So one important thing, I just wanted to use this opportunity to just sort of make everyone aware of this one particular lesser known service or lesser known facility that we have called as the data science VM. As startups, a lot of startups want to do experiments. They want to quickly get up and running with a data science project. And setting up a data science environment can be a daunting task, as all of us have probably experienced. It's a lot of tools, lot of compatibility issues between tools and things like that. It can take a long time to set up an environment where you can even before start your data science experiment. So we have something called as a data science VM, and I just spend a little time on this just to sort of make everyone aware. So we have this data science VM, which is available on the Azure Marketplace. It's as the name suggests, it's a virtual machine. So you just basically go to the Azure Marketplace and click create or a VM. And along with this VM, what you get is a pre-installed set of tools that you can see on the screen right now. Almost anything that you need in data science is available on this VM. Whether it's TensorFlow, Keras, any ONNX, whatever you need from development tools, different data platforms, Spark, all the things that you need to actually work with a data science project is all available to you as a ready-made VM. So I urge everyone to just sort of try this out, go see if you have some need of doing data science immediately without having to spend a lot of time in setting up an environment, then this is a good way to start. So, with that, I wanted to start with some of the common architecture patterns, that are seen in the industry. So one of the very basic ones is the modern data warehouse that I mentioned. If you actually, let me just turn on my pointer here. So if you see the lower end of it, which is basically from the business and the custom apps to a data factory and directly going into a data warehouse, this is the traditional, I would say the traditional data warehouse. You could, in the olden on-prem SQL world, you could actually see that this could be an SSIS kind of a package that is actually delivering data into a data warehouse or an analytical service, SQL Server analytical services, and then from there it's consumed into reports. So what's really changed now is the fact that you now have unstructured data coming in, which now needs to be processed separately. So we have something called as Azure Data Factory in the cloud that can help you do that. And since this is unstructured data, it might need more processing and more data engineering on top of it. So you don't directly put it into you rarely directly put it into a data warehouse. You probably store it into a blob storage for someone to actually take a look at it and then use it. Let's say you have clean data already and which can be directly used by, say, a SQL data warehouse. Then you can use technologies like Polybase, which can directly fetch data from the blob store into the data warehouse and run your queries. So Polybase is one of our key technologies that we have recently introduced, maybe about a year, 2 years ago, which allows you to fetch data from. Yeah.
So Aniruddha, sorry to disturb you, but can't see the slide. There's some issue where we can't advance can't see.
You see now?
Seeing the hexagonal. I'm still seeing the hexagonal slide.
Oh, is it?
Yeah. Yeah. Now it's.
Now.
Just a second. It's still at the common architectures patterns slide for some reason. Can you stay on the modern data warehouse slide?
Yeah.
So that there's a little lag, I think.
Are you able to see now?
No, not yet. It's stuck at common architectures pattern for some reason.
Now?
No, can you just unshare and reshare? Maybe starting with that. I don't know why we are having this issue. Generally, it works fine.
Are you able to see now?
No, not yet. Yeah, we can see it now.
Okay. Okay. So as I was saying, basically the lower end is the traditional data warehouse, and the top portion is the one which is an addition due to the unstructured data formats. And we were talking about Polybase as a way of getting unstructured data or any kind of other so even from a structured database from external to SQL that you can get into SQL data warehouse. And it's a very interesting piece of technology which basically allows you to execute queries, and it does it in a way where the query actually gets executed in the source system sometimes if it is a like a Hadoop cluster or something like that, so that the compute of the data warehouse is not used, and it basically just builds a table out of the data and brings it into the data warehouse for you to process. So very interesting piece of technology again, where if you want to directly get some data, external data into data warehouse. Otherwise, you can use technologies like Databricks again to just prep and train your system. So look at the data, see what it has, build models, train the models, make sure that the model is efficient before you actually move it into some sort of a analytical services and publish it to a Power BI or some consumption. So that's the modern data warehouse architecture, the simple one. Yeah. Are you able to see advanced analytics now?
Yes, yes, we are able to see advanced analytics.
I think it's only after a few slides that it is sort of slowing down. So we'll just manage. So advanced analytics again is something which is a slight variation of the modern data warehouse, where you might have to do more advanced machine learning algorithms. So you might use more than just Databricks. You could use Azure machine learning, which will give you a plethora of libraries available, open source libraries available for you to do the machine learning part of it. And it might be a little bit more sophisticated, training and more sophisticated algorithms.
Yeah, some of Aniruddha, some of them I'm not able to see. Can you go back and do? I think I don't know if it's a bandwidth issue on some people's side or some issue on our sense side, because
are they able to see now?
Just a sec. I'm still seeing the modern data warehouse slide. Yeah, now we can see.
But are others able to see? I don't know.
Yeah, I guess they are able to see. Yeah.
Okay. Okay, so the advanced analytics is just a twist on top of the modern data warehouse, where you're doing even more analytics. So the analytics part of it is even more sophisticated, where you're using advanced machine learning techniques. So you might use something more than Databricks, like Azure machine learning and things like that, to build your models. Not much of a difference, just that the models could be a bit more sophisticated. So the next one is a real-time analytics. Are you able to see that, Vinayak?
Yeah, I'm able to see it.
Yeah. So real-time analytics is more of streaming data. So this could be IoT data. This could be clickstream data coming from your apps. It could be other media being streamed. Whatever it is. I mean, it's basically continuous data that is coming into the system. So no longer a simple blob store would help. So you have to sort of put it through some sort of a streaming architecture like a Kafka or an IoT hub, which can basically ingest data at that speed. And then use that data through a store. Again, you can either put it into a blob store for historical analysis, or you could do real-time analytics on it, and get your models and then publish them. So these are more real-time analytics where you want to monitor maybe a running car or maybe a factory or something like that, which needs real-time analytics, and it can't wait. Everything has to be done almost near immediately. So let's move to some business scenarios as to what are some of these scenarios that that various industries are using. Yeah, are you able to see the big data analytics slide, Vinayak?
Yeah, I'm able to see.
Okay.
Abhi,
So,
can you please check? Yeah. Yeah, please go. Yeah.
Okay, so here are some here's a slide which basically takes a bunch of industries and shows you examples of how you could use big data analytics on top of it. What's interesting here is that every business, it's not like, it's not that analytics is just about forecasting or only about predicting and things like that. You can take any core business tenants of any industry. So in finance, for example, forecasting, risk management, and fraud prevention are definitely, I would say, the top three things that drives the finance industry or a finance company, right? I mean, if you can manage these three things and manage it in a way where you are able to predict what is happening and are able to stop fraud before it happens, or even make sure that you're giving loans to only those people who are really, so any kind of risk management that you can do, you will definitely be successful. And so same applies for manufacturing, where again 3 different tenants can be used, and advanced analytics can be applied to those tenants. So it's not really about that, advanced analytics can be used only by a certain industry and not by certain other industries. No matter what industry you're in, if you can find those top tenants that you want complete control on and be able to predict what that thing should be or what that tenant should lead to, you can basically apply big data analytics to it and manage your business really efficiently. So here are some examples of big data and advanced analytics impact with examples. While the first few examples are more of big companies kind of examples, I would like to talk a little bit about the last one, which is Jet.com. So Jet.com, as many of you might already know, is basically an online retailer company, a startup that started just a few years ago. And has now been bought by Walmart. They based their entire business on a very simple thing or a simple concept called dynamic pricing. So they were able to basically take all the elements of pricing a particular product to a particular user. It involved the middlemen commissions that are, or the people who are involved in the middle, their commissions, the transportation, the warehousing, all those costs were very, very, sort of granularly calculated, and very individualistic prices were given to users. And the prices were dynamic, which means that if a certain product suddenly starts if a lot of people start putting it into their basket, it actually impacted the price of that item for others. And this could only be done through really advanced machine learning that they used. And today they've been basically bought by Walmart, and Walmart actually has gained a huge advantage, online advantage, by actually getting their technology in there. So this is an example of, again, something that started with data as their center. And they knew that and a business that basically just was completely hinged on data and advanced analytics. So just to sort of give you an example, like the templates that I had up there were more like standard architecture templates. But if you have to actually take a scenario like a connected user experience, what would that architecture look like? So, this is how it would look like. You would basically have, again, unstructured data coming from different open databases or open systems, which will be pumped into a Spark or a R server or on HDN site, so that you can do your recommendation engines on that. The recommendations could actually be put into an Azure Cosmos DB, which is, again, a simple, very high throughput data model or a framework, which will allow you to sort of pump these to the mobile apps and web apps and things like that. So just as an example, a very recent project that we completed with one of our customers, a financial consumer finance company customer, they actually used this in a very, very nice way, where they actually had this recommendation engine or a recommendation system that they used to run every day for their customers. And it would take almost about 10 to 12 hours to actually run the entire system. So they, even after they started building ML based algorithms on it, but then it started becoming even more complex and to run. So they moved it to the cloud. They not only moved it to the ML also to the cloud, but they also realized that the storage also was quite slow. So they switched to Cosmos DB for high throughput. And today that 12-hour job runs in about 1.5 to 2 hours. So in the morning itself, they are able to generate the offer, send it out to their customers before it's too late, and the day while the offers are fresh. So these are the kind of things you can achieve in the cloud, by putting up architectures like these. And then at the end, you have, of course, your connected consumers, which are taking using the mobile apps and all with notifications and things like that. There are many other examples of how an app could actually benefit from advanced analytics. Let's say a salesperson on the road, just imagine if every day in the morning they get a list of hot leads that they should be chasing that day, and it's based on a prediction or some sort of a classification algorithm that tells that these are the people who will definitely or most probably buy something today or whatever it is, or maybe can be serviced today for some of the products, or it could be offers, or it could be very granular things like this particular offer can be given to this particular customer because the data shows that they need it. Right, so those kind of things can be directly delivered to an application rather than going through a reporting system, and made available to their users very immediately. So with that, let's take our first product, which is basically the Synapse Analytics, which is a new name for our SQL data warehouse. So the erstwhile SQL data warehouse that we had is now called Synapse Analytics, and I'll just explain why that is and what that is in a bit. Are you able to see Vinayak, the screens?
No, actually still stuck on the last slide.
Which is Synapse?
No, common experience in retail.
Okay. So let me just share again. I think that is solving the problem.
Kabir, can you share the slides? Maybe there's some issue on his side. Do you want to take over the slides?
Are you able to see now, Vinayak?
No, we are not able to see. Some issue. I'll ask Kabir to do the slides just in case. Yeah. Let's go ahead.
Okay. Next one.
Yeah, we are at the Synapse slide, and yeah.
Okay.
Now it is syncing.
No,
yeah.
I can't see the slide. Okay. Yes, now I can see the slide. Yeah. So are you on the slide with the two circles, right? Vinayak?
No, I'm not able to see the slide with the two circles. Yeah, I think there's a little bit of lag. I think there is about a 10-second lag, but now we can see it.
Yeah. So let's just, I think, continue with resharing or something like that. Do you want to continue like this, Kabir, or Vinayak, or do you want me to? Okay.
It's visible now, so let's continue. I'll check with Kabir also. He can take over if we have.
No, so he is presenting right now.
Okay, cool. Then this is fine.
Okay. So traditionally businesses have been maintaining, for the past few decades, the companies have been maintaining two separate silos when it comes to structured and unstructured analytics. So they had some concepts of data lake where there was like some sort of a blob store or a Hadoop cluster or something like that was being maintained, and on the other side they had their structured OLTP databases being maintained in the form of a data warehouse. Which is their operational database, and they kept sort of working between these two things, and in fact I personally was in those times where I was helping customers where they were wanting to use portions of their relational database in their big data, and side of analytics, and we were talking about things like concepts of data warehouse federation, for example, where and obviously if you try to make a query from your data lake to your data warehouse, then you put a lot of burden on the data warehouse for those queries and things like that. So people started making copies of their data warehouses and making it available for big data to actually access it from there. So it became again a very complicated system of things, and it became very difficult to sort of do a more holistic analysis across these two silos. So if you can move to the next slide, Kabir. So what Microsoft decided is that, hey, is there a way to sort of take these two things and merge them together? We already have the data lake technology. We have the data warehouse. Can we do something to the data warehouse where the data warehouse can handle, big data kind of analytics on top of it? Can the storage be merged? Can all these different tools like Data Factory and Azure ML and all that be put into one sort of a system that will give you that access to all the tools, all the storage required to do data warehouse and big data analytics together? So if you move to the next slide, Kabir. Yeah, and so that basically makes it, Azure Synapse Analytics, which is our now a flagship project or a product for data warehousing and big data analytics. It is in preview right now, so certain things are not available. Certain things are available only in private preview. Some of the things are available as GA. So you can actually go to your Azure subscription and maybe start a data warehouse, SQL data warehouse cluster. But there are certain things that may not be available to you, like real-time queries and things like that. Yeah, next slide. Yeah. So what it really gives you is first of all limitless scale. So it gives you the ability to scale compute, and have massive storage, petabytes of storage that you can put on the cloud, and will allow you to scale, which allow you to sort of go up and down from a compute perspective to make sure that you are able to take up that load, and that is where on-demand query and provisioned both are available. Where you can, so every business will have a certain a certain requirement where certain reports are run. Maybe a daily report is run in the evening, maybe some daily systems are run, or maybe some monthly systems are run, and things like that, which are very routine sort of analytics workloads that run, and you want to provision for that. These are all known workloads. There's nothing surprising about it. So might as well just provision the resources so that when these things run, they run very quickly and get done. But there's always this on-demand query. There's often surprises in the business, and you suddenly want to run some analytics, on the fly analytics on the system, where there might be some sudden workload coming in. So how do you cater to that? So you can actually you can start something called as on-demand query service, and you can handle those queries coming in, which are sort of on-the-fly queries, and you pay for obviously as the resources get used, and use it only at times when you need that service. Otherwise, your regular provision data warehouse will continue servicing the regular queries. Powerful insights, again, because of the tools integrated in it. So you have Power BI, you have Azure ML, and all these other tools that are integrated into the system itself, so that it will give you that powerful insights. From that, you can run experiments within the same environment before you can do any any exploration work that needs to be done before you can build your models. You have a unified experience because there's one studio, which is the Synapse Analytics Studio, which gives you everything. So right from ingestion to analytics to publishing the models, everything happens through one environment. And so it makes it a very unified experience rather than jumping between tools. And of course, unmatched security, because once everything is centralized, our Active Directory, granular, security will sort of run through the whole thing and make sure that people are accessing the models and the databases according to their access rights. Can we go to the next one? Yeah. So you can complete the slide. There's some animation here. So if you look at it, again from what's really included in the data warehouse is, other than scale and the very popular MPP, the massively parallel processing architecture of SQL Server that also comes with it. One particular thing that I would like to point on this slide is this last one, which is basically pay for what you need and a dynamic pause. So this is again a feature that is being used very heavily by especially startups. Traditionally, large enterprises have a tendency of leaving their data warehouses running all the time. They probably can afford it. They don't really have ever wondered about the cost involved and things like that. So the traditional way of running the data warehouse is to always keep it running because you already paid for it on-prem, and you just sort of go and get whenever anybody needs any data, they just run queries against it. But we have seen some really, some of the startups who use it so judiciously, and it's amazing to see that something like a data warehouse, they don't run it all the time. It's always paused. During a time when they actually need to query something, they batch up all their queries together. They start the data warehouse, they run their queries, and then they pause it again. This helps them save a lot of cost. They are not paying for all those resources continuously running, and it's an amazing way of a very, very revolutionary way of running a data warehouse. So that's something again possible through Azure SQL Data Warehouse, that you can leverage in the cloud. Next one. Yeah. So from an architecture perspective, this is what it looks like. So you have the typical MPP architecture, which has a control node and then a multiple set of compute nodes. The compute nodes are separated from the storage nodes as such, so that they can be scaled independently and they don't have to depend on the database or on the storage. And as a query gets submitted to a control node, the control node will basically take the query, analyze the query, split it into parts that can be executed in parallel. And you can basically run and distribute it across the compute nodes to execute the portions in parallel. However, not every portion is going to be completely independent from a data perspective. There are portions of it that might need data from other compute nodes. And that is where in our first version of SQL Data Warehouse, we actually had something called as a data movement service, which is actually a service sitting at every compute and control node, and does the job of moving data from one compute node to the other as each service or each query portion needs that data. And what we realized is that this is something that's a lot of traffic. It leads to a lot of latency, and is not really the best way to keep moving data from here to there, and it's a waste of a lot of resources and time. So in our new version, the latest version, that is the Gen 2 of Data Warehouse, what we have done, can you click once, Kabir? Yeah. So what we have done is we have gotten away with the data movement service. We said that is not the best way to do it. And click one more time, Kabir. And what we have done is basically we have created temp DBs. So every compute node now has a temp DB. And these temp DBs and the compute nodes basically query each other's temp DB directly. For any data that is required, and if that data needs, if it is being frequently fetched, then obviously it's made a portion of that temp DB itself, so that it never again needs to be fetched from anywhere. And this has basically resulted in a lot less traffic. A lot of most required data gets duplicated across these temp DBs very quickly. And then we are able to really achieve a lot of scale. So that's one change that has recently happened. There is a link in the resources section where I have which I have shared, where this architecture is also explained, and along with that there is a video from our product team which actually explains how this thing works, how this TempDB thing works, and how it actually helps really scale well. Yeah, next slide. Yeah. So yeah, we'll go step by step. So let me just take this off, what Azure's Synapse Analytics is all about and what it bundles together as a package. So at the bottom is basically a data lake store, which basically also helps, consolidate all that data into something called as a common data model. So a common data model is nothing else but a mapping. It's a very simple. So since you are getting data from different sources, you are getting data from, Twitter, and you're getting data from all different, other sources, and plus your structured sources, it is important to get everything into a common data model. And what that really means is basically mapping. Which means that date of birth might be called differently in different sources, and we just need to have a common data model which says DOB or something like that, which basically means date of birth. Similarly, other things can be mapped so that you have a common model to work with, and your models can have a common nomenclature across the data. Just click one more time. Yeah. So the data integration layer. Or actually, Kabir, just click through. I think there's a lot of animation on this one. We'll waste a lot of time. Yeah, one more. Yeah. So the data integration layer basically gets this data into the Synapse workspace. And once it's in the workspace, you now have a facility of running different runtimes on it. So your traditional SQL runtimes can run using SQL queries. But if you want to do any batch processing or micro batch processing kind of this, and you need a Spark kind of an environment, then that is also built into the Synapse Analytics itself. So you don't have to work on creating that separately. And your on-demand queries or all other sort of batch related queries and all can run against these two runtimes and actually do the querying. So you could have provisioned queries or you could have on-demand queries as a form factor of getting your data. From a language support perspective, we have everything. We almost SQL, Python, .NET, Java, Scala are everything that you need to actually run your analytics. So if you have some advanced machine learning kind of work going on, you can use your Python R skills to do that. And everything from an experience perspective is bundled into Synapse Analytics Studio, which basically gives you that common experience, of working with all these tools together. So the management, security, monitoring, and the Metastore all is part of the analytics itself. So as you see, a lot of things. Basically, so Synapse is not really something that has been newly built, grounds up kind of a thing. We have done some tweaks to our SQL Server engines to make it, more sort of big data analytics kind of an engine. But overall, it's just basically nothing else but getting all those tools together and removing the headache of provisioning all these environments and running all these systems as disparate systems rather than working in when you can work in a single environment. So that is what Synapse Analytics is all about. Can we go to the next one? Yeah. So after Synapse Analytics, I wanted to cover is the Data Explorer. So a little bit about Data Explorer and what it does and why is the need for it. And as startups, I'm sure you understand this more than anyone. That as startups, you are basically creating new businesses. You're creating new models of businesses. So there is not much of an experience available in the market, or maybe you're absolute sort of new concepts that you're introducing. And so maybe standard models don't apply, and you need to really research what models work for you, what is the right model for you. And there's very little experience from that you can get from any previous implementations or best practices. So it is important to explore your data and find patterns, and before you can actually come up with your algorithms and say, yes, this is what I'm going to use. So that exploration becomes a big challenge when especially you have disparate data sources. You have SQL, SQL can only query. You have some sort of visualization tools which are again separate to actually visualize it. So if you actually have to query these data from different sources, different unstructured sources, get it into a system and then visualize it to see patterns, it is going to take a lot of work. And that's exactly where Azure Data Explorer comes in. So can we move to the next one? Yeah. So if you look at that, or if you remember that previous traditional data warehouse or modern data warehouse that I diagram that I shared, basically nothing else but a new block has been introduced in that entire this of something called as Explore. Right, which you basically say that, hey, I don't know, I don't want to sort of decide my models before I actually see the patterns and then figure out what models I'm going to use. So this exploratory phase is the one where Azure Data Explorer will come in and will help you from an exploration perspective. Next one. Yeah. So what it provides is, again, basically a fully managed service. So you don't have to worry about anything. All you have to do is start a cluster, create a cluster, start your data explorer, connect it to that cluster, get data into that cluster, which again is a matter of, just basically plugging different event hub or whatever into your storage. You can pump, as you can see, almost about 200 MB per second per node that can be pumped into the system, and then basically use a very unique query to a query language to actually do your work. And I'll show you the example in my demo. You will see what that is. It's a combination of SQL and Python, C#, and piping kind of languages, a combination of all that that allows you to do these sort of time series analytics or anything of that sort. So the idea is clearly to work with streaming data, because that is what is really critical and has to be done in real time. So you have click streams coming in, you have IoT data coming in, or whatever is your business where there is data continuously coming in, and you need to find a pattern before you can come up with a model for processing that data. Next one. Yeah. So it gives you, as an overview, basically it gives you the capabilities to manage different data types. So you have structured, unstructured data, or semi-structured data, not really unstructured, but semi-structured data. You have option of streaming ingestion or batch ingestion. So you can bulk copy the data, or you could attach it to an event hub or something like that. As you can see in the diagram, you have IoT hub and you have Kafka and everything that can be synced to the store, and so you can get continuous data coming in. You have compute storage isolation, so you can again run a compute cluster on top of it, so that you can scale independently. And then again multiple options to actually through APIs and SDKs connect to the Explorer data and the results and things like that, rather than or you could use the Data Explorer UI itself to do your exploration. Next one. Yeah, from an ingestion perspective, again, you could get it from event grids. You could use Logstash, Kafka. All these different APIs are available. So you can use Node, REST API, Python, Java, .NET, any of these to actually access the Explorer service itself. And any kind of those storage systems mentioned here as event grid, event hub, or blob store or data lake that can be used to basically source the data into the Data Explorer. Next. Yeah. So intuitive query, I'll skip this. I'll just directly go to the demo and just show you what it actually means. Yeah, so this is again a chart from an ingestion and consumption perspective. So these are the various options available, basically nothing else but a summary of everything that I just talked about. So from an ingestion, from the left-hand side is all the ingestion tools that are available. On the right-hand side, all the ways of actually connecting to the Data Explorer and getting your job done. Yeah, next. Yeah. So how do you set up Data Explorer? So you basically sign on into the Azure portal. You create this. So at this point, Kabir, can I take over? I like to, because I'll have to shift to a demo. Yeah. Can you see my screen, Vinayak?
Yeah, we can see it.
Okay, so this is my Azure portal, and what you can do is basically, as I mentioned, let me see if I can. Yeah, so you create a Azure Data Explorer cluster. So if I go up here and I just type in, you will see that thing come up here. So you create that cluster. You go to that creation screen, click on create. And supply the the required data, and I'm not going to do it right now because it just takes time. Right now we'll use a sample cluster, but just to sort of show you what I mean by creating a Data Explorer cluster. So you can just basically supply your data here from a subscription perspective. You can select the compute that you need. So you have different different sizes of compute that is available. So whether you want a very high storage cache, high cache, high memory kind of a this, or depending on what's your CPU and what's your processing requirement, you can select one of these as your compute target, and then create the cluster. Once you create the cluster, you basically click on the dataexplorer.azure.com, which will, so once you create the cluster, you also have to create the database. So once you go to the cluster, there will be a button to create the database itself. Actually, I have a, okay, maybe I close that. So you can create the database, and into that database you can basically pump your data. So whether it's coming from Event Hub or whether it's coming from some sort of a bulk upload, that's up to you. You basically copy the data or get the data into that database. Then you open the Data Explorer, connect this cluster to that Data Explorer, and you're done. And we'll see how that works. So if I click on it, so we have in case of Data Explorer, we have a sample environment available for you to experiment. So if you go to this particular URL, which is samples databases/samples, you will actually find sample databases there that you can play around with. So I'm going to switch to that. Yeah. Are you able to see my screen now, Vinayak?
Yes. Also, Aniruddha, we're almost out of time. So,
oh, okay. Oh, is it? Okay. So let me just quickly cover. I just have one more demo, and then we can with the automated ML. So how much time do I have?
maybe another 5 minutes, and then we can take Q&A.
Okay. Okay, so Data Explorer, again, as you can see here, there are various demos being built. Somebody has already started working on the coronavirus databases and things like that. But here is a demo series database, which is nothing else but a time series database. I can click this and I can, run a very quick query saying, let's say take 10, and just run this, and it will give me my 10 records or whatever it is from the series. Okay. Sorry. So it's just the connection getting refreshed. But I can also take up some advanced kind of scenario. So let me just take one of them at least. Let's say I want to do a time series analysis of a particular series. Then I can just this here. So just describing this query, we first three statements are describing the the min max time of the the chart that I want to plot. There is a 2-hour sort of a step given, and then if I want to sort of like a piped this, so I want to render a time chart. The time chart is nothing else but a series decompose of the series itself, which will give me which will decompose the entire series into a baseline, seasonal, and residual kind of this. I'm going to use a condition saying that where the SID is TS1, and then make series where I'm going to tell them the min, max, and the step that is to be done, and finally the database to be used. So if I run this, yeah. So as you can see, I have a chart here, and I can sort of see the baseline. I can see the rest, the seasonal. So I can, if I switch off everything else, I can just click on these things, switch off those charts, and get only the relevant data that I need. And finally, I am plotting a trend to see what actually the trend is based on that. So the residual is basically nothing else but a difference of the seasonal and the baseline, and then a trend chart that goes through it to tell me the trend of my series itself. So this kind of analysis to be done very quickly. As you can see, I didn't have to do anything, just run this query, and I was able to quickly get a chart and analyze it. So let me switch to the next one, which is basically our automated machine learning. Very quickly, I will skip the slides a little bit and directly go to the demo and give you first maybe give you a little brief on it so that you understand what it is. So automated ML, as you know, ML in general is a very iterative process. You have to run experiments and run it again and again to train it, check again the efficiency of the algorithms and things like that. It can be a very daunting task to do, very, very time consuming also to continuously. So if you look at an ML development process, this is from the scikit-learn cheat sheet. Just imagine the amount of decisions that a data scientist has to make to get to the right algorithm. It's a very time consuming thing. So Microsoft Research basically came up with a concept of something called as automated ML, where we actually run these things for you. And we run the efficiencies on those algorithms. And at the end, we tell you what is the right algorithm and the right hyperparameters to be used for your algorithm. So that you don't have to spend time doing these iterations on the machine learning. So let me just quickly switch to the demo and just show that part. So machine learning, again, Azure Machine Learning, just like Data Explorer, is a URL. You just go to ml.azure.com. You will come up with a page which will ask you for your subscription and things like that, and a ML space that you need to create on Azure. Once you have that, you will be brought to this screen, and you can see that you have, you can manage your notebooks, you can manage your data sets and everything in this environment of machine learning, Azure Machine Learning. We are going to go to something called as automated ML. And if I click on new automated ML, it will actually ask me to sort of run the, give me the sources, so I can point it to a data source. I can ask him what parameters or what is the prediction. If it's a classification algorithm, is it a prediction algorithm to be done? What are the parameters to be predicted or classified, and things like that. And at the end, it will basically give me a run. It will actually take all that and run through various combinations of this. So just to sort of show you what those combinations look like, here's the run that I had already performed on this. So it's a banking data where I'm trying to predict an incoming customer, whether he will open or he or she will open a fixed deposit or not. That's the prediction to be done. And so classification this. So just take a look at this. This is the number of algorithms that automated ML ran for me, different algorithms. It also figured out the efficiency using the AUC weighted method. and sorted all the algorithms by that and told me what's the best algorithm. So it's the voting, ensemble, which is the best algorithm that should be used, right? I can further go and look at this model. I can click on it. And also look at the visualizations of this as to how it has been, how it has come to that conclusion. So it will actually draw all the charts for me and things like that, and just sort of show me the so just to sort of show you the process of the final slide in terms of how this works. So it's basically taking your user inputs. It is putting those inputs into a bunch of algorithms with features, engineered features, and is actually training it against the score. And once it is done running all these iterations against various algorithms, it will basically come up with a leaderboard saying, hey, this particular algorithm has the best score. So here's the charts you get. So as you can see, the calibration curve is an almost perfect fit from the ideal and the points that it has gotten from that algorithm, and that's why it has been chosen as the best algorithm by the automated ML. And so that's pretty much it. This is what I had in my presentation. I wanted to do one little conclusion as such as to why would you use PaaS-based analytics and ML. One, it saves you a lot of time in terms of setup. It helps you accelerate your innovation as a result of that. You can quickly get started, experiment, and then scale up accordingly. So you don't have to make large investments upfront. There are a lot of out-of-the-box tools available, and the fact that you're not paying a lot. If you do all this on a VM, just remember that the VM is charged until they are deleted. So which means, with PaaS services, that's one of the biggest benefits, that if you're not using anything, then you don't pay for anything at all except for storage. Storage is one of the cheapest things on the web, and that's the only thing you pay for, but the compute and everything goes down to zero. So those are the advantages of why you would use PaaS-based analytics on ML. So now we can, I think, open it up for Q&A, Vinayak.
Yeah, so the first question is from Amit Singh. So just a second, I'll just pull up his question. So he's asking, do we have certification programs for Synapse Analytics as well?
So not yet, because it is yet to be GA'd. There is that you can get certifications on maybe a data warehouse, SQL data warehouse, which will be very similar, but not on Synapse Analytics yet, because the product has not completely released yet. So the access to the Analytics Studio itself, for example, is a controlled access. You won't be able to get access to it until we release it, and you ask for it, and we think that yes, So it's in a private preview right now. But the data warehouse part of it you can get.
Okay, there was one more question related to recommendation systems. Just a second, I'll pull that up. So as a newbie, Farisa Basroor asks, as a newbie in the field for building a search engine, recommendation-based engine, recommending on user feedback, would this be the right platform to start with? Please share your insights with us.
Yeah, so for you, I would recommend. So if I go back to just one slide here, just to sort of answer that question. Let me see when you see it. Yeah, do you see this slide? Vinayak, are you able to see it? Machine learning on Azure?
Just a sec. I'm still at the resources.
Okay. Okay. So anyway, I'll answer the question. So in the Azure world, we have a whole bunch of services when it comes to AI and ML. One of the services we have are called the cognitive services, which basically are include vision, text, search, language, speech related services. As a part of that, we have something called as Bing Search, or a search service. Ideally, I would use that. if you want to do any recommendation based or any sort of ML based search engines you want to build. If you want to build something that you need to search over internal sources of your system or of your internal documents and maybe a catalog and things like that, then we have something called as Azure Cognitive Search, which will help you do that in and allow you to do it in a natural language query, or even do vision-based searches where you can submit a picture and then do those kind of things. So if you want to do that, I would recommend that you use our cognitive services, where you can find the answers to doing search-related services.
Cool. So I think that's about it for the questions. So we can stop here, and what we'll do is we'll post a link to the video and the slides, post this webinar to all of the participants.
Yes.
So you can go back and refer to it. And also we have the winner of the swag bag. It is Amit Singh. So you will have a goodie bag coming to you soon, Amit. Yeah, be posted. We'll post it to you soon. So
Okay.
thanks Aniruddha. With that, we'll stop here, and hope to see you in the next webinar on next Thursday.
Sure.
Yeah, thank you guys.
Thank you everybody for taking the time.
Thanks. Bye.
Thank you.